Alrighty, what is going on? Got another video here for you. This is statistics, and we're going to talk about bar graphs, circle graphs or pie charts, and time series graphs. So let's go ahead and get started. Alright, so here we've got features of a bar graph. The bars can be vertical or horizontal, and you can see in this example here they're vertical. And we could draw them this way if we wanted to, horizontal. Bars are of uniform width and uniformly spaced. So the width of each bar is going to be the same. They're going to be equally spaced. The lengths of the bars represent values of the variables being displayed, the frequency of occurrence, or the percentage of occurrence. So based on whatever your frequency is, or whatever the data you have, that's going to tell you how tall the bar is, how high to draw it. And the graph is well annotated with title, labels for each bar, and vertical scale or actual value for the length of each bar. All right, so what we have here is we have a bar graph that's showing the life expectancies for men and women born in these years, 1980, 1990, 2000, and 2010. And these are the life expectancies. So the blue represents men, the orange represents women. So you can see in 1980, the life expectancy for men is 70, for women it's 77.4 years of age, and so on for each year. And this is just an example. This is actually called a clustered bar graph because there's two bars. See, there's two bars for each year. So that's what that is. And the length of each bar represents the life expectancy. So, that's all it is. You just, you have your label for the year, and this axis over here, the 20, 40, 60, 80, 100, that represents the how old they are, the age, and this represents the year of birth. You just draw a bar, and that's all it is. Now, another thing you can do is, you see how it starts at 0 and it goes 20, 40, 60, 80, 100. Another thing you can do, I didn't make another graph of this. For one, I didn't actually know how to do this in Excel, but since the numbers go up so high, the numbers get kind of big. Instead of starting at, you can start at 0, but instead of your first number being 20, you could actually start your first number at 60 or 65, something like that. And the way we would do that is we would have to put this squiggle in here. Okay. And we could start this at, say, 65, 70, 75, 80, 85. And, it's so that you can, so the intervals here aren't so far apart. You've got 20 between each number. You can make it 5 between each number, but you don't want to go 5, 10, 15, 20, 25, 30, all the way up to 85 or 100. So we can just break the graph here and start at 65. So, and we talked about this in the last video. So, if that first number is not to scale with the rest of them, then you want to put that little squiggle in there, that little break there. Okay. And so that's pretty much the bar graph. That's what a bar graph is. Okay, they're pretty simple. I'm not going to draw the bars on there. The main thing I wanted to point out here is this thing right here. If you didn't want to make it to that first number, if you didn't want it to be to scale. All right, so the next kind of graph we're going to look at is a Pareto chart. So a Pareto chart is a bar graph, okay? Right there, it's a bar graph in which the bar height represents frequency of an event. In addition, the bars are arranged from left to right according to decreasing height. So basically, it's going to look like a bar graph. I mean, and in this one, we're not going to have double bars at one category. We'll just have one bar there. But for a Pareto chart, the main thing here is you've got to arrange them in order from largest to smallest, going left to right. So let's look at this example. It says, suppose you want to arrive at college 15 minutes before your class. And I didn't type up the whole problem, but sometimes there's reasons that cause you to be late. So what causes you to arrive late? And here's a list that somebody made out that makes them arrive to class late. So snoozing after the alarm goes off, that's happened 15 times. Having car trouble, that's happened 5, and so on. These are the reasons that they arrived late and how many times it happened. So they were late for class quite a bit. Don't be late for class. All right, so it says make a Pareto chart showing the causes for lateness. So you can see we have to go all the way up to 20. So I'll draw a axis here. We'll go across here, and let's just go 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. All right, so now we're going to have our categories. So you can see here that our first category, we're not going to write down snoozing alarm first for our first bar. We're going to write last minute studying down first, okay, because you can see that's happened the most. Then it will be snoozing the alarm, and then too long over breakfast, and then we've got talking too long with roommate, finding something to wear, car trouble, and then other. So we'll have to put them in that order. All right. So for this one, we will put study. It's this one right here, last minute studying. I'm not going to write the whole thing on all of them. And that has happened 20 times, you can see. So this bar is going to go all the way up. And I know I'm not drawing it straight or perfectly straight, but that's happened 20 times. And then our next one is snoozing the alarm. So we've got snoozing, and that has happened 15 times. So we're going to go all the way up here to 15. And I know this looks messy, but and keep in mind these bars here, I know they don't look good, but they're the same width. Okay, just bear with me. And then the next one was where is it? Breakfast. So we've got breakfast, and that was 13 times. So we're going to go all the way up to here. And then the next one is talking too long with roommate, so running your mouth basically. So talk, and that happened 9 times. Right there. And then we have dress, finding something to wear. We all know that's important. So we've got dress, and that happened 8 times. So, I mean, you get the idea of what's going on here. And then we've got the car, and we have other. And the car was 5 times car trouble, and other was 3. So we're going to go up to 5 here and 3 here. And there's your Pareto chart. All right, so I mean, and look, that's how you would draw a bar graph also. It's just for a bar graph, you wouldn't have to worry about putting them in order, okay? All right. So now let's look at a circle graph or pie chart. So in a circle graph or pie chart, wedges of a circle visually display proportional parts of the total population that share a common characteristic. So let's look at an example. How long do we spend talking on the telephone after 5 p.m.? The results from a recent survey of 500 people are shown in the table. So less than half an hour is 296 times, or 296 people talk less than half an hour. Half hour to an hour, 83 people, and more than 1 hour, 121 people. And you will notice that this right here, these numbers here, they total up to the 500. Okay, so these represent the number of people. All right, and we want to draw a circle graph. All right, so how do we do that? Well, we've got to get some information. We need to get the fractional part, the percentage, and number of degrees. So the big question is, how in the world do we do that? Okay, so the fractional part, so what fraction of people talk less than half an hour? Well, that would be the 296 divided by 500. That's the fractional part. For this one, it would be 83 divided by 500, and this one would be 121 divided by 500. So what percentage is that? Okay, what percentage? Well, we know how to find the percentage. We take the 296, divide that by 500. We punch that into a calculator, and we get 0.592. We get 0.592 as an answer. But they are asking for the percentage. So how do we get percentage? Move it 2 places to the right. So that's 59.2%. I mean, you don't have to put the percent sign because the heading says percentage, so we know that's percentage. All right, and then for the next one, 83 divided by 500, 83 divided by 500, that's 0.166. 0.166, move it twice, 2 decimal places to the right, so that's 16.6%. And then the 121 divided by 500, that is 0.242, so that is 24.2%. So there's our percentages. Now, how do we get the number of degrees? Okay, so for the first one, 59.2%. So we take the 59.2% and multiply it by 360 degrees. All right, so in reality, what we're doing is taking 0.592 times 360 degrees, and that gives us, we're going to say 213 degrees. So it's actually, let's say 0.592 times 360 is actually 213.12 degrees. We're just going to say 213. Okay. All right. Now for the next one, we've got 16.6% times 360 degrees, which is going to be 0.166. We convert it to a decimal to multiply it to the 360 degrees. And so 0.166 times 360. That is equal to 59.76 degrees. 59.76 degrees. So I think what we're going to do here, we're going to just go ahead and round that up to 60 degrees. Now, do you do that? It really just depends on what your teacher wants you to do. If you're in my class, I would say round it up to the nearest, round it to the nearest whole number. Okay. It'll just make it a little bit easier to do these graphs, and plus you'll see when I start to draw my circle graph, you're not going to get these angles exactly right. Okay, but you know, it's going to give you an idea. And then for the last one, we've got 24.2% times 360 degrees, which is 0.242 times 360 degrees. 0.242 times 360. That actually comes out to 87.12 degrees, and we are going to call that 87 degrees. I'm just rounding. Okay. If you're not sure if you need to round or not, ask your teacher. All right. So now let's draw our circle graph. All right. So this ought to be fun. There's my circle. Okay. Yeah, I know it's horrible. Let's see. I don't know if I have. Do I have where I can enter in a shape? I probably do, but I'm not going to waste a lot of time trying to figure out how to do it. But anyway, let's just draw it. We'll just draw it the best we can. So that's good enough. There's the center of the circle. And so what we do is we'll call this, there's your 0 degrees. And we need to rotate this around 213 degrees. And so we're going to say that 213, if we go straight across to here, that's 180. And so we would need to go a little bit more for 213 degrees. Okay. And so we'll call this 213 degrees. And we will say this is less than 1/2 hour. And that is 59.2%. All right. Well, I mean, I don't know if you want to put the degrees in there. You typically put the percentage in there. And then we've got 60 degrees. So from this line, we need to rotate 60 degrees. So let's see, 213 plus 60 is 273. So you know this goes up. This would be 90 degrees. This would be 180. And then if we go straight down, that's 270. But we need to go 273. So we're going to be about right in here. And so this would be your 60 degrees here. And this would be 1/2 hour to 1 hour. 1/2 hour to 1 hour. And that is 16.6%. And then this last one, that's going to be the 87 degrees that's left over. And so this is actually your 24.2%. And this would be more than, more than 1 hour. Okay, and once again, you know, this right here, let's see, let's just kind of move that up a little bit. And so, you know, this is your 213 degrees, this is 60 degrees, and this would be 87 degrees. And if you add up all of these degrees here, these right here, if you add all those up, you'll see that that does equal 360 degrees. Okay. All right, so that's your circle graph. I mean, the main thing is, getting how much, figuring out how much you need to rotate, how much piece of that circle each one of them takes up. And that's by going and finding the fractional part, your percentage, and then multiplying the percentage times 360 degrees to get your degrees here. All right, so that's your circle graph. All right, so the last one, it says in a time series graph, data are plotted in order of occurrence at regular intervals over a period of time. And time series data consist of measurements of the same variable for the same subject taken at regular intervals over a period of time. And here's an example. Suppose you have been in the walking, jogging exercise program for 20 weeks, and for each week you have recorded the distance you covered in 30 minutes. Your data is shown below. So you can see each of these is the distance that you've covered over 30 minutes. And this is week 1 through week 20. And these represent the distances that you covered in those 30 minutes. And they want us to make a time series graph. All right, so basically all you're doing here is plotting points. This is like your X coordinate and this is like your Y coordinate. Okay. So let's go ahead and draw this. I wish I could draw straight line. It's kind of tough drawing a straight line on this screen here because it's so slippery. Let's call that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. We got it all on the screen. And then let's look and see what our lowest, our smallest, and largest number are. So it looks like we'll start out at 1. It looks like our smallest number is like 1.4. And our largest number looks like 2.7. So we need to go up to 3. So we'll call this 1, 2, 3. Let's do this as 1.5. Let's do this as 2.5. And so here we go. We're going to plot 1.5. So that's going to be right there. And then we've got 2, 1.4. And that's going to be a little below. And then 3, 1.7. So 3, 1.7, that's going to be a little above. Okay. And then 4, 1.6, 4, 1.6, that'll be a little bit lower. And so hopefully you get the idea of what's going on. Let me move that up just a little. I mean, it's not, drawing these things, if you could put in the 1.1, the 1.2, you can do that to get a better idea. But, it is what it is. So I'm going to pause the video while I fill in the rest of the dots, plot the rest of the points. Hopefully you see how I'm doing it, and then I'll start back after I plot them. All right, so we've got all the points plotted. And yeah, I know it doesn't look that good, but anyway. All right, so then what we'll do is we'll connect them with line segments. And your scale could be better, but And there it is. There's your time series graph. Now, you know, it's good that we did that, but can we kind of tell what's going on? Okay, from just looking at the graph, if we knew these were running times and stuff. So, you know, we might want to label this week and this distance in miles. All right. So if we looked at this, could we tell anything from it? Well, sure. We can tell that it looks like the miles that we're covering, it looks like it's increasing, doesn't it? So, you know, that's one good thing about graphs. You can actually look at the graph and kind of and get an idea of what's going on. That's why it's, you know, it's nice to have these pictures that we can look at instead of just, I mean, because if you just looked at all this data right here, you know, can you tell anything from it? Well, maybe not, but when we look at the graph, we can see it better. Okay. All right. And so that's all of this video. I hope it helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I will see y'all in the next one. Later.